Jeroen is joining us from the beautiful Eindhoven High Tech Campus.
Yeah, exactly right.
We had a innovations festival yesterday, so to say.
Yeah, yeah, I wasn't there personally, but I've heard from colleagues it was great fun, a lot of networking, a lot of demonstrators as well. So
Always fun to be in the Eindhoven area, I need to admit.
exactly.
Slides are looking good, Jeroen. One thing, could you click the hide
Yeah,
button?
there we go.
Perfect. And the stage is yours, Jeroen. I might jump in at the 10-minute mark and tell you that we are short on time.
Yeah,
Very good.
I'll I'll
Stage
wait
is
for you.
yours.
Yeah, thanks. All right. Well, good morning, everyone. Thanks for joining. I'm Jeroen from the Holst Center, where I research the future of printed electronics, and I would like to take you all with on a journey towards what we feel is going to be the future of 3D printed electronics and the technology we've designed for that and are building now, which we call 3D additive lithography for electronics, towards high throughput, high resolution printing of functional structural electronics. Now, why 3D printed electronics? Of course, there is already what we call subtractive fabrication techniques, such as how PCBs are made. They are very performant, they work great. However, there's a lot of material waste during production, and when designing them, it's essentially still two-dimensional, so there's limited freedom, and you might go for a flex PCB, but even then, it's essentially still two-dimensional. Um, a sort of a technique alongside, which is slightly more additive, slightly less wasteful, is in-mold electronics, where essentially the PCB is replaced by a three-dimensional substrate, but essentially it's still a two-dimensional circuit design. So you're still restricted to planar electronics, and typically SMD components as well. And that's where we feel 3D printing can enter the scene and make some moves there. Because 3D printing, we feel, should allow for rapid prototyping of device designs, full 3D free-form designs in structure, both interconnects and incorporated devices. There's limited material waste because the only material that's used is what goes into the object. And most importantly, perhaps for sort of smaller scale production, is that there's no product specific tooling needed. So you could make essentially one-off products and you wouldn't need separate masks or separate screens to do that. However, there's already a couple of technologies that are being used for 3D printed electronics, such as inkjet or dispensing methods, but they are comparatively slow. And with our technique, we aim to improve on that. And that is where uh, what we call 3D ALE, 3D additive lithography for electronics, comes in. So 3D ALE is the whole center's 3D printed electronics technology designed for scalable production of microelectronics with a freeform three-dimensional design. This is the prototype tool that we've been building and are improving on every single day. It's fully custom, in-house built. And with this machine, we've so far been able to print very small polymer objects with integrated interconnect structures, as you can see in the top image, or also integrated, heterogeneously integrated pair die components. And the combination of these two, integrated interconnects as well as pair dies, we feel is going to lead to highly integrated um, small polymer electronics. So what we aim to achieve in the future is multifunctional products. So in a single packaging, incorporate both electrical parts as well as microfluidics, optics, as well as radio frequency antennas. So we can print small objects that are fully integrated and can serve many different functions. Now, I would like to have you understand how the process works, sort of. And to that end, I will take you along the processing steps. It all starts with printing cavities for the components to fit in. I should mention these pictures resemble an older generation of our process, so they have been improved since, but they do highlight the process very neatly. In these cavities that we print, we then put in the components. I should also note that the structural material in this case is a photopolymer resin, meaning that we start off with a liquid formulation of unreacted chemicals, and then through patterned ultraviolet